2 missing characters in a regex pattern, that's all it took to compromise every AWS-managed GitHub repository. Wait, are you saying attackers could inject code into AWS's own repos?
So we're covering how code breach works, which repos were vulnerable, and how to audit your dependencies.
By minute 4, you'll know exactly how to check if you're exposed. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into 2 missing characters, how a regex flaw exposed AWS GitHub repos to supply chain risk.
Stick around to the end for this week's headlines. Let's dive right in.
So let's talk about how 2 missing characters in a regular expression almost compromise the entire AWS supply chain. This code breach vulnerability is fascinating because it shows how even the most sophisticated tech companies can fall victim to the simplest coding mistakes.
2 characters? That's it? We're talking about AWS here. They have some of the best security engineers in the world.
That's exactly what makes this so concerning. The vulnerability was an AWS code builds integration with GitHub repositories. Basically, their regex pattern for validating webhook URLs was missing 2 critical characters, a caret and a $sign.
Oh, wow. So without proper anchoring, the regex would match partial strings instead of exact matches.
Exactly. Instead of matching only legitimate AWS domains, it would accept any URL that contained the pattern anywhere in the string. So an attacker could register something like awscodebuildevil.com, and it would pass validation.
That's terrifyingly simple. And this affected AWS-managed open-source repositories?
Not just any repositories, we're talking about popular AWS SDKs and tools that thousands of companies depend on. The attack vector here is particularly clever. An attacker could potentially inject malicious code into build processes, and that code would propagate to every application built using those compromised tools.
But surely there were other security controls in place. AWS wouldn't rely on just regex validation for something this critical.
You'd think so, but this highlights a fundamental problem in modern software development. We've built these incredibly complex systems with multiple layers of abstraction, and sometimes the most basic security principles get overlooked. The researchers who discovered this found that once you bypass the regex check, you could actually trigger builds with arbitrary code.
How long was this vulnerability exposed?
That's the million-dollar question. AWS hasn't disclosed the full timeline, but based on the code history, it could have been there since CodeBuild's GitHub integration was first implemented. We're potentially talking years of exposure.
This reminds me of the SolarWinds attack, but almost worse in a way. At least with SolarWinds, the attackers had to compromise an actual company. Here, they just needed to understand regex.
And that's what keeps me up at night about supply chain security. We've seen this pattern before. CodeCov, CircleCI, now this. Each time, it's the build and deployment infrastructure that gets targeted. Coming up, we'll dig into exactly how an attacker could have exploited this vulnerability and what it means for every company using cloud-native build systems. Not necessarily. The researchers found that by controlling the webhook endpoint, they could manipulate the build process itself. CodeBuild uses these webhooks to determine what code to build and when. By sending crafted responses, an attacker could potentially trick CodeBuild into building code from a different source or injecting additional build steps.
Wow. So we're talking about potential arbitrary code execution in the build environment.
Potentially, yes. And remember, these build environments often have access to production secrets, deployment credentials, and signing certificates. The blast radius here is enormous. Let me give you some concrete numbers to put this in perspective. AWS CodeBuild processes millions of builds per month. Even if only a small percentage of those were compromised, we're talking about thousands of potentially infected applications.
What about detection? Surely there would be logs or alerts if someone was manipulating builds.
That's the insidious part. Because the attacker would be using the legitimate webhook mechanism, their activities would look like normal GitHub integration traffic. Unless you were specifically looking for anomalous webhook sources or unexpected build behaviors, this could fly completely under the radar.
And I imagine most teams aren't monitoring their build systems that closely. They assume AWS is handling the security.
That's the shared responsibility model paradox. AWS secures the infrastructure, but customers are responsible for how they use it. Except in this case, the vulnerability was in AWS's own code managing their own repositories. It blurs the lines of who's responsible for what.
Let's talk about the broader implications. This isn't just about AWS, right? Every CI/CD platform that integrates with GitHub has similar webhook validation code.
Absolutely. I'd bet money that security teams at every major CI/CD provider scrambled to audit their regex patterns after this disclosure. And it's not just regex. Any input validation vulnerability in build systems becomes a supply chain risk multiplier.
Have we seen any evidence of this being exploited in the wild?
AWS says they haven't found evidence of exploitation, but honestly, how would you even know? If an attacker was smart about it, they'd make minimal changes, maybe just adding a small backdoor or exfiltrating secrets, rather than obvious malicious code. The SolarWinds attackers operated for months without detection, and they were modifying actual compiled binaries.
Speaking of SolarWinds, how does this compare in terms of potential impact?
In some ways, this could have been worse. SolarWinds affected about 18,000 customers, but they were high-value targets, government agencies, Fortune 500 companies. A compromise of AWS's core SDKs could affect hundreds of thousands of applications, from startups to enterprises. The scale is just different.
And unlike SolarWinds, where the attackers needed sophisticated persistence mechanisms, here they just needed to understand basic web security.
That's what's so frustrating about this. We spend millions on advanced threat detection, AI-powered security tools, and complex zero-trust architectures, and then a missing regex anchor undermines it all. Stick around. In our final segment, we'll give you the exact checklist for auditing your own build systems and protecting against these types of vulnerabilities. All right, let's get practical. If you're a platform engineer listening to this, what should you actually do? First and foremost, you need to audit every webhook integration in your build pipeline.
Should teams be looking for specific patterns, like is it just regex issues or broader validation problems?
It's broader than just regex. Here's my 5-point audit checklist. First, webhook URL validation. Make sure you're using strict pattern matching with proper anchoring. Second, verify SSL certificates on webhook endpoints. Don't just accept any HTTPS connection.
Oh, that's a good point. Certificate pinning would have prevented this attack even with the bad regex.
Exactly. Third, implement webhook signature verification. GitHub, GitLab, and most platforms support HMAX signatures. Use them. Fourth, monitor and alert on new webhook registrations. If a new endpoint suddenly appears, that should trigger a review.
What about the build environment itself? Even with perfect webhook security, there are other attack vectors.
Absolutely. Fifth on my list, implement build isolation. Every build should run in an ephemeral, isolated environment with minimal permissions. And here's something most teams miss. Rotate your build credentials regularly. I'm talking weekly, not annually.
Weekly? That seems aggressive. Won't that create operational overhead?
Sure, but compare that overhead to a supply chain compromise. Automate the rotation. Use short-lived tokens wherever possible. AWS STS, GitHub's installation tokens, whatever your platform supports. The days of long-lived CI/CD credentials are over.
What about detection? How would a team know if their build system was compromised?
Great question. You need to baseline your build behavior. Track metrics like build duration, resource usage, network connections, and files accessed. Any significant deviation should trigger an alert. Also, implement deterministic builds where possible. If the same source code produces different artifacts, that's a red flag.
Oh, reproducible builds. That's been a big push in the open source community.
Exactly. And it's not just for security. It helps with debugging and compliance, too. Here's another practical tip. Implement a build attestation system. Every build should produce a signed manifest of exactly what was built, from what sources, with what dependencies.
That sounds like what SLSA framework is trying to standardize.
Precisely. SLSA, Supply Chain Levels for Software Artifacts, provides a great framework for this. Even reaching SLSA Level 2 would have made this code breach vulnerability much harder to exploit.
Looking forward, what should platform teams be watching for? This won't be the last supply chain vulnerability.
The next frontier is AI-assisted coding tools. As we integrate more AI into our development pipelines, we're creating new attack surfaces. Imagine if an attacker could poison the training data for GitHub Copilot or manipulate AI code reviews. The regex vulnerability is simple compared to what's coming.
That's a scary thought. Are there any positive developments in supply chain security?
Actually, yes. The industry response to these attacks has been impressive. We're seeing better tooling, standards like SBOM and SLSA gaining adoption, and major investments in build security. Google's binary authorization, AWS's code signing, GitHub's artifact attestations, these are all direct responses to supply chain threats.
And the fact that this vulnerability was found by security researchers rather than exploited by attackers is encouraging.
That's a great point. The responsible disclosure ecosystem is working. But here's my closing thought. We need to fundamentally rethink how we approach build system security. Right now, we treat CI/CD as a development productivity tool first and a security-critical system second. That needs to flip.
So less move fast and break things and more move carefully and secure things?
I'd phrase it as move fast and verify everything. Speed and security aren't mutually exclusive if you build the right foundations. And that's really what platform engineering is all about, creating those secure, scalable foundations that development teams can build on with confidence. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in the world of Linux security. Pebbled Ventures has created an AI tool that's analyzing 2 decades worth of Linux kernel bugs. Jinny Guani Kwa's team has built this system that combines neural networks to predict potential vulnerabilities before they become problems.
Wow, 20 years of bug data? That's an incredible data set to work with. How accurate are these predictions?
The new stack reports it's showing promising results by identifying patterns in kernel commits that historically led to security issues. This could be a game changer for platform engineers managing Linux-based infrastructure.
Speaking of game changers, the Cloudcast just dropped 10 thought-provoking questions about what Cloud 2.0 might look like. They're exploring everything from new architectures to how it'll impact businesses.
Cloud 2.0? Are we talking about a complete paradigm shift here?
They're suggesting we might see fundamental changes in how we approach cloud computing, things like edge-native architectures and AI-first design principles. Platform engineers should definitely check out their full podcast episode.
Now, here's something unexpected. TechCrunch is reporting that Apple plans to unveil a Gemini-powered Siri assistant next month.
Wait, Apple using Google's AI models? That's quite the partnership.
Apparently, this update will let Siri access user data more intelligently to fulfill those AI promises Apple made earlier. Could be interesting for developers building voice-enabled platform tools.
And speaking of updates, Pulumi just dropped version 3.217.0 with some significant improvements.
What's new in this release?
The big headline feature is OIDC JWT claim extraction during login. They've added the ability to pull organization, team, and user information directly from JWT claims, which should streamline authentication workflows for platform teams.
That's going to make identity management so much cleaner for enterprises using Pulumi. Any other notable features?
They've also made some engine improvements, though the release notes got cut off. But the OIDC enhancement alone makes this a worthwhile upgrade for teams managing infrastructure as code.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.